Hi everyone and Assalamualaikum. Today I will explain about our mini project for subject ECG263. This study investigates the effectiveness of rice husk as a recycled material for soil stabilization. Rice husk is an agricultural byproduct generated during the rice milling process and is produced in large quantities in many rice-producing countries. Instead of being disposed of as waste, rice husk can be reused as a sustainable construction material due to its lightweight nature and high silica content, which may contribute to improving soil engineering properties. For this project, we have to conduct two types of tests. First, attribute limits. Second is standard proctor compaction test. Methodology of standard proctor compaction test. Material preparation. Firstly, we prepare a total dry mix of 3,500 gram consisting of 3,325 gram, which is 95% soil, and 175 gram, which is 5% replacement with a sustainable material. Truly dry mix component until uniform. For compaction, we place the prepared soil material mixture in the proctor mold in 3 equal layers. We compact each layer with 25 blows using a 2.5 kg rammer dropped from 305 mm. Then, after the final layer, we carefully trim the excess soil and weight the compacted mold to determine the bulk density. We take a representative sample to oven dry for 24 hours to determine moisture content. Then, we repeat the procedure using incrementally different moisture content to obtain a series of dry density values. These values are plotted to determine the optimum moisture content OMC and maximum dry density MDD.
Okey, timbang.
From this graph, we observe that OMC is 18.15%, MDD is 1.67 gram over cm cube.
I will explain the methodology of the attribute limit test. The objective of this test is to determine the liquid limit, plastic limit and plasticity index, and to compare the properties of untreated soil with soil mixed with rice husk. First, the soil was air-dried, crushed and sieved. Then, rice husk was mixed with one of the soil samples and water was added gradually to obtain different moisture content. Next, the liquid limit test was carried out using the cone penetration method to determine the water content at the liquid state. After that, the plastic limit test was conducted by rolling the soil into 3 mm diameter threads. When the threads started to crumble, the moisture content was measured. Finally, the plasticity index was calculated using the formula plasticity index equals to liquid limit minus plastic limit, and the result of both soil samples were compared. Based on the result, As the water content increased, the cone penetration also increased for both soil samples. This happened because higher water content made the soil softer, allowing the cone to penetrate deeper. Both graphs showed a positive relationship between water content and cone penetration. In addition, the soil mix with rice husk had a smaller range of water content, which indicates improved soil stability. The addition of rice husk also reduced the soil's plasticity and improved its consistency. This means the treated soil is more suitable for construction because it is less affected by change in moisture content. However, the result may have been affected by some experimental errors such as inaccurate weighing, uneven mixing, incorrect cone penetration readings, and water evaporation before weighing. In conclusion, the standard proctor test showed that adding rice husk increased the maximum dry density and reduced the optimum moisture content, which indicates better soil compaction. For the attribute limit test, the addition of rice husk increased the plastic limit and changed the liquid limit, showing that the soil consistency had improved. Overall, rice husk reduced the soil's plasticity, improved its stability, and has good potential as an environmentally friendly soil stabilizer for civil engineering application.